So we'll start sharply at 8 o'clock. And we should be starting with the question answer. And the first question would be that you should be able to understand that the subject is absolutely easy and interesting. Why it is easy? Because now computer is with you. You just need to appraise something and it will come to you. Another thing, this is also very easy to understand, the difference between statistics and mathematics. I asked a question a few days ago, not all of you were not there, that if 1 plus 1 is equal to 2 is known as mathematics, while if the quantity is near to the 1, add another quantity which is near to the 1, then it will not be exactly 2, but it will be near to 2. So this is the difference, that approximate value which you get, that is statistics. Thank you. So basically, mathematics is 1 is equal to 1, 1 plus 1 is equal to 2, that is mathematics. If anything is near to 1, you add another thing which is near to 1, then the amount will not be exactly 2, but it will be near to 2. And that near to 2, how near it is, that if you want to find out, then we use the statistics. In our medical field, what usually happens that if you are giving a medicine, it is not 100% sure that patient will survive. Patient may die. But then, what is the probability of a survival? Or for a cancer patient, what is the probability that the cancer patient will survive for 2 years, for survival for 5 years, which is known as survival statistics, or it is also known as life table. And based on life table, they are finding out what will be the survival rate. For example, if you bring a fan in your house and a guarantee is given for 2 years or 3 years, that depends on the life table. The company finds out that after how many years usually my fan will go away. They say it is 2 years, then they will give usually 2 years warranty. And then they have a calculation that even if few people come, there won't be a problem. So in a statistics is basically a science of a probability, find out the probability. In this case, yesterday we started using Epi Info. So the 42% who have joined, anybody who is having the problem in using Epi Info, you can just narrate your problem. Tomorrow onwards, you can contact the Mr. Hitesh. I already given your number. He will attach with the team viewer with your computer and install, and if required, just teach the command read. He doesn't know much of the statistics. Another fellow will come into picture after 2 to 3 days. Is a Mr. Kalpesh. And if you have any problem in running the show, he may also guide you during the day. And rest of the problems you can always share in the groups. Now our next thing will be on the Monday. And Monday, by that time, most of you must have used Epi Info. Why I say the Epi Info? So it is easier, it is interesting, and you can start right away, start doing your own analysis. That is the reason. So now today, let me have at least feedback of someone, and then I start. Any question? So if there is no question, I presume that all of you have installed the Epi Info starter it. So we'll just spend maybe 5-10 minutes for that. So if you are not able to import the data in the Epi Info, then your Excel version, you should downgrade, save as, you should downgrade the Excel version, then it will accept. Today I will see, I will share my screen and you can see that we'll spend around 10-15 minutes for Epi Info, and then we'll be moving towards understanding the most important concept of p-value. If I use the fluently, then you may confuse. I will be talking about standard deviation, standard error of mean, standard error of proportion, and standard error of difference between two mean, standard error of difference between two proportion. All these things I'll be taking today. I wanted to use the blackboard or whiteboard in the computer, but the moment I started whiteboard, so many people started writing on it. So I will find out tomorrow another technology, and next Monday probably I will be able to use the blackboard without any problem. So I hope that all of you have by now use the Epi Info, at least may or may not be able to use it. So let's go for Epi Info. It's starting a Epi Info over here. Now, the most important thing where your file lies and whether Epi Info can identify it or not. That is the crux of the matter. So what happens that you should know where is your file. So first, let us say how to find out the Excel. So if your Excel file is over here, if it is not accepting, then you can go file over here and save as, and for example, you want to save somewhere in this or maybe on the desktop. And let's see, session 1 or desktop you want to save. And here you are given the various options. And in this case, if you use Excel 97 2003, mostly there won't be a problem in importing the data, because Epi Info is also progressing fast, but the Microsoft is much faster than the Epi Info. That's why sometimes we need to go for older version. So here it is the older version, XLS, that you can select. So right now, so I know that this is my file, and now I will be analyzing it with Epi Info. Now, first command read. Here, you should be clear that whether you are importing from the project or you are selecting from Excel. So, if it is an older version, it will take. Newer version, it may not take. And this is a concept of project. Epi Info project means there could be several tables. Here, when I say table, the word is equivalent to the Excel sheets. In that, they may use the word table. So basically, a single database, such as 10 or 20 database, you can have in the single project. Just I re-emphasize the thing that if you have a data of a village, then you have a data of a family, then you have a data of an individual. So if you have a database of a village and you have 100 variables, all 100 variables you did not write in all the families also. You just connect only one unique code of that village in each family, then automatically the village data will be get attached with the family. This is known as a relational database. Will not be using that command over here, but that is very important command. Other thing, in a family, there are 100 variables. So when you create a database for an individual, at that time in each individual, you need not add all this family data. Automatically, if you have a key field while adding the individual, key field of family. And in family, you have a key field of village. Then what will happen that automatically in that individual, you will be able to collect the data of the family and also data of village. So if you want to compare the citizens of, let's say, Gujarat and citizen of Uttar Pradesh, then you will have automatic data linking that will be possible. And that is important when you want to find out what is the difference in diabetic patients of Gujarat and diabetic patient of Uttar Pradesh. At that time, all the characters of Uttar Pradesh and all the characters of Gujarat should get attached to the individual. And that is relational database is very important. Those who are having a pen and pencil should write down this one word. So the thing is, you should write down relational database. This is very important in Epi Info. And if you use this, it will be easier for you to do the various projects. And particularly in ecological correlation, this is useful. Ecological means that in a one area, you have a temperature, humidity, or road condition, electricity, the socioeconomic condition, etc. Other area, you are also having the same thing. And when you want to compare this effect on the health or diseases, at that time, this is very useful. Now, I'm starting with Excel file. And when you fail to do this, with the help of TeamViewer, we'll be able to do it. I know where I kept my file. That you should also know. It is in session 1. This is a party.xls. And see, remember that Epi Info is a notorious only to start with. Once you start it, then there are no other problems. And sometimes, because it is working with Microsoft, by linking the Microsoft database, Access database, that can be a problem. Now, there could be in Excel, there will be 10 or 15 seats also. You need to give which seat you would like to select. So far, while selecting this database, anything difficult over here? Dr. Anupam Banerjee, what do you think? Is very easy? I didn't got the answer. Yeah. So, 2 commands yesterday we learned. Today we'll be going for the 3rd command of means. Here, first, let's go for frequency. Just a minute. મારે છે સોમવાર ને બુધવાર 8 થી 9:30 લેક્ચર હોય છે ત્યારે ફોન નહીં કરવાનો. અત્યારે છે કે કામ? હા હા જે લેવાય લઈ લો નાખું છું બાપ. જે લેવાય લઈ લો. Sorry for disturbance. So frequency is the first thing which you can do so that you know that what is to be analyzed, what is not to be analyzed. So you can select like this, one by one, cabbage, or you can select coffee like this. Or if you don't want to do like this, you can select all. There is another method. Here you can use the word all, except you don't want to have names, because what is there in the name? This is very important. Name you don't want to have frequency. Then, suppose you don't want to have age at present. There will be so much thing. And age you can later on go for the grouping also if you require. And then you, these 2 variables you don't want, right? So you all accept this. And if you press OK over here, you will get everything except those two things, right? So this frequency command, wonderful and very easy, right? Now you might wonder that after this table is there is something like exact 95% correlate. Why this also is given along with this? So for this, I'm going very slowly because you need to understand that this is a cumulative percentage. For example, when you want to find out the percentile, at that time, cumulative percent will be useful. Here, you won't find much useful. But when we go for the age like this, frequency of age, see, here the cumulative percent will be useful. It's the percentile, basically. If I tell you that 13 is how many percentiles, then you can say that 10.67. That means 10.67% of the people are having age 13 or less than that. If we go somewhere over here, if I ask you, how many are there above the 63 years? How many people are there above 63 years? That means upper 20th percentile or more than 80 percentile. So more than 80 percentile are how many people are there? So 20%. So more than 63 years, 20%. Because 80%, you 100 minus 80. So 20% are over here. Now this will be useful to find out percentile directly. Less than 2.5%, more than 2.5%. Those things we can find out from here also. But then why this long distance is given over here? This shows that how many people are having age 50 years. Here you can say that 50 years, 2.67% are having age 50 years. In this data, out of 75 people, 2 people are having age 50 years. But suppose this 75 people, I hope everybody is attentive. Suppose this 75 people are selected from 1 lakh population or selected randomly from 10,000 population. Then what will be the proportion of the age exact 50 years in that population? So that population will have a range between 0.32% to 9.3%. This is a range which reflects that this will be the proportion of people having age 50 years in the population from which this sample was taken. I end over here. So you should understand this point. This is why these are given. Right. So far, once we have understood the frequency and reading these limits, etc., I will wait over here for some question. Somebody has asked the question. While getting frequencies, for example, in age, the rows are not arranged sequentially, 1, 2, 3, etc. It is not arranged sequentially because computer says that 25 is less than 3 because it is according to ABCD. If you want to arrange like this, then you should be writing 0, 3, 0, 1, 0, 2 like this. When you collect the data, then there won't be it is not a haphazard. Computer has perfectly arranged the data as per the ascending thing. Because 2, 3 is more than 2. That's why it ignores the 5. So if you want to have this 3 earlier than 10, then you should write as a 0, 3. So it is not haphazard. Thank you, Dr. Banerjee, for asking the question. Can the frequency come sequentially as suggested in increasing order age? So this is a solution. So let me go for another examples. So once you know the frequency, ideally you should write down this frequency or take a printout of the frequency. You should have frequency with yourself. And based on that, you should find out how many tables to be found out. I will ask you a very, very simple question. All of you are so intelligent that immediately you will be able to give answer. Suppose I have 10 variables in my format. All variables are characteristic variable. That means you are describing it, right? Like here, diabetes, yes or no, potato taken or not, vanilla taken or not, characteristic variable. I have only 10 variables. So how many tables I can formulate? How many tables I can formulate? If I have a 10, I can go for the only bivariate analysis. I'm not talking multivariate analysis. Just 2 by 2 table, how many types of 2 by 2 table I can have? So please write the in chat box. This is a very important question, particularly for those who are doing dissertation. You will be able to find so many new things if you adapt this system. So write in chat box. I repeat my question. If you are given a dissertation work where you are having 10 variables, all variables are qualitative. That means you don't have anything, something like mean or like that. So wonderful. People have started giving us 10 variables. You need to have permutation combination between any two. And it should be unique one. I should not get repeated. So answer, people have started 10, 100. Wonderful. Just go on 100. Wonderful. I will give you a hint. When you go to a bus, sometimes they have written a distance between two random places, Borivali to Kandivali, Kandivali to the, let's say, Santa Cruz, like that. So answer is not 100. So answer is 10 into 10, but then is 100 minus 10. That is 90 divided by 2. The answer is 45. So how do you do it? Say you prepare a 10 by 10 table. I'm so unfortunate. I wanted to use it, the board, but I could not use it. But then the next time we'll do it. So imagine that 10 variables you have written horizontally and 10 you have written vertically. Let me open this Excel file, and so that I can just tell you. This is very important for those who have yet to do dissertation work, or you are doing some research work. So it's a variable that V1, V2, or you can say the gender, or you can say the diabetes, variable V3, like that. 4, 5, 6, 7, 8, 9. These are the variable. 10. And let me remove this gender and diabetes to make it a simple. So I will transpose this. This is what you should be doing when you are doing a dissertation. Transpose and insert or cells right. So the same variable you are using over here. Okay. Now, see, 10 by 10, 100 tables are there. But if I use this, V1 against V1, it will be give you the frequency. This is also frequency, right? And I hope that all the PG students should know this. This is very simple, very easy, but equally important. Understand? So this 10 will be removed. So out of 10 into 10, 100 tables, 10 are only frequencies because they are going against matching you itself. So you will get only frequency. You are not going to get a table out of it. Agreed? Now, see, if you compare V2 and V1, the same thing V2 and V1 will be over here. So it is a mirror image. So this is a V2 versus V1. And that's a mirror image. Same thing will be over here. Right. So similarly, all this upper half and lower half, you can use only one. So if you remove this upper half, then this will be with you. So out of 90 remaining, you need to use half of it. That means you will have 45 tables to match, right? And here you should write down the importance. You just write down V1 and V2. How much is the importance? V1 and V3, how much is the importance? Suppose here you have a milk and here you have illness, right? Here you have a vanilla. And here 8 is vanilla. So what will happen then when you go for your dissertation work, when you go for analysis? So before analysis, how many, whatever maybe your variables are 10, 20, 30, 40. Suppose you have a 40, then the answer will be 40 into 40. That is 1600. 600 minus 40, that is 1560. Divide by 2, that will be the answer. That much work you are supposed to do. So what you can do that V1 and V2, for example, right? Here is also milk. So while comparing milk and V2, you say importance is 2. And then milk and illness, importance is 8. Milk and vanilla, importance is 3. Something like that. So is a hypothetical, you think this is correlating with each other. So how much people will like milk and the vanilla also? What is the likelihood that there will be correlation between these two? That you can put it over here. What is the likelihood of illness and the, for example, illness and milk? So it is over here, so you do not put it over here. Then illness and vanilla, you say that it may be 5. So this you can do it, make a total, and based on that, you will work on the Epi Info, that which tables you would like to have. So I'm closing this. Before that, if there is any question, very necessary. Sir, in the chat box, I would not like to have any appreciation. There is a request because I look at the chat box. If you have any problem, appreciation, you can later on give it to me personally, because sir, it distracts me. So now this is what is to be required for UGs, PGs, and those who start a project, that there could be something beyond what you have thought, and it may come out. Now, once you have done this, let's go back again to Epi Info. So now you know the read command, you know the frequency command, and now we are going for the tables command. In exposure variable, yesterday we know that there was a vanilla and the outcome was the illness. This table command, I think you can use very well. But if all you agree, should I give you one more details? Can Dr. Gargi reply? Should we go further in detail? Are you ready to grasp?
Yes, sir.
Then I will reduce your job. Just add something over here. That is the gender. So what will happen? What Epi Info will tell you, that it will remove the effect of the gender. And independent of that, it will tell you whether the illness and vanilla are affecting each other or not. There's a very interesting example with Epi Info. Maybe around 1 or 2 decades ago, I did an analysis of a physician. I'm repeating this many times because it is a live example. It was a true example that a physician came to me telling that, look, sir, there's a very good relationship between the urinary creatinine level and the glycosylated hemoglobin. So why not to do just urinary creatinine and find out glycosylated hemoglobin? I think it's wonderful. Let's find out your status is proper or not. When we remove the confounding variable of age, there was no relationship. So it might be that because of the women like more vanilla, and because of womenhood they fail and they fall to illness. Then in that case, we need to remove that. What happens in the male? What happens in the female when they are exposed to the vanilla? So independent of that, if we want to find out this, then we'll go for okay. So now this is first, the Epi Info is giving you analysis for the females in which you can see the result. If they are not taken, 23% female were illness. See here the horizontal and vertical percentage are there. There is no hurry. Just look at the table, horizontal and vertical. The raw percentage means, I hope everybody is over here, 13 females had not taken vanilla. So out of that, 3 felt ill, that means 23%. And out of 31, female took a vanilla, in which 27, that means 87% felt ill. So there is a difference. Now, what is that difference? Whether it's significant or not, that is automatically given in the tables. Now, before that, if you look at this vertical data, how many were ill? That means 30 females were ill and 14 were not ill. 13 who were ill, out of that, how many percent took vanilla? 10%. And 14 who were not sick, for 71% didn't took vanilla. So this is a vertical reading and a horizontal reading. Raw percentage, column percentage. You can use whatever way you want to use it. Now here, if you look at the p-value, it is 0.0003. And in male, let us see what is that p-value. Here it is there. And here the p-value is 0.0006. So the probability of event occurring by chance was here, it was 6, 0.0006. It was 0.00004. If you look this, then 0.003. So it is more significant in female compared to the male. It shows it, right? But then there is a adjusted odds ratio here, and this is a little bit advanced one, but this is, I'm showing you that this is also automatically calculated by Epi Info and adjusted for the sex, because that you had written in comparison, whether it is a male or female. So you forget this adjustment, but you just remember there is something like tables when you can compare anything. You want to find out who took more fruit salad. Here it is not an exposure and outcome variable, but we just want to compare between two variables. That is also okay. The choice of fruit salad, was there a significant difference between male or female or not? If that is the question, the answer is no significant difference in the choice between male and female as far as the choosing fruit salad is concerned, because you can see the two-tailed p-test over here. One-tail, two-tail will talk sometimes, but then the p-value you can at least see over here. Now, in this case, because the expected cell is much less than 5, you cannot use this uncorrected. You should be using corrected test. While we talk about chi-square test, we'll be using that. But then this is giving. So far, You are now, I suppose, can teach others the read file, read command, the frequency command, tables command. Third command which we are going to use is the means. What is the mean difference of age between those who are sick and those who are not sick? And whether this difference is significant or not. Now here you should write down in your notebook that whenever there is a command given to you, whenever there is a variable view, which is where you can find out the mean. I use the word quantitative command for a quantitative variable. Here you should not try to group as far as possible. At international level, if you're going to present your papers, try not to break up into the groups. If possible, try to use direct the mean of the values. And if at all you want to make a grouping, you should go for the preparing the normal distribution curve. And if there is a sharp turn at some point of time, then you can go for grouping. Otherwise, preferably not. So here, means of age. You should remember that means of, if you write this means of chocolate, it is not good. It is not the right thing. You can't find out mean of the chocolate. So you write down means of the age. Now you want to cross tabulate by, you want to find out illness. Whether there is any role of age in causing illness or not. This is a simple table. We'll take some time over here to read this table. I hope you are keeping pace with this. So 0 means no illness. How many observations? 29. 1, there's illness. How many? 46 people fell ill. Now the word mean is 32, while the 1, 39. What does it mean? The people who fell ill were having mean age of 39 years compared to the 32 years who were not sick. So means there is some difference. Now, when we talk about the variance and standard deviation, there is a relationship between standard deviation and mean also. So, if there is a mean is 32 and standard deviation is 20, what will be the standard deviation if mean is 100? I repeat, standard deviation is 20 when the mean is 32. What will be the standard deviation if there is a mean is 100? That means 100 into 20 divided by 32. That will give you coefficient of variance, CV. Why this is important? So, if you compare these two, standard deviation, then in next 39 mean, in that there is 21 standard deviation. So standard deviation is much more in those who were not sick compared to the poor people who were sick. So that's a little bit more detailed kind of analysis, but because you're so learned people, you should be comparing these two also. So what is the coefficient variance? And then mean, mode, median is also that you probably know. The percentile also, you know, everything is given. But now let us go for the p-value. You can use the t-test, you can use the f-test. And that again, when we go for the diagnostic flowchart, when you should be using t, when you should be using the f-test, at that time we'll take it. But at present, you just understand what is the p-value. Here, you go for f-statistics, 1.5, p-value is 0.2. So, although age seems to be a significant difference on a first seeing 32 and 39, but we look at the statistical analysis, the difference is not significant. So, this is a means table, means how you use the means command. So we just use the read command, frequency command, tables and means. Now, sometimes you have a project with you and you have done a data entry in Epi Info itself. Then you go for the read command and then select Epi Info project, then browse, and you should know where is your file lying. Now here it creates a problem. So your folder, where is the folder? Epi Info folder and projects. This is, if you try, and project file. So you need to search where is your Epi Info folder. In your Epi Info folder, you try it out, you will be able to find the project file. And that project file, I'm just showing, there are in that project, so many baby blood pressure, so many things, but we are now sticking only to the Oswego. It will take some time, depending on the speed of your computer. So 75 data selected. That analysis I did from the Excel. Now I am doing directly from the project file. Same command, read. Read, already we use the command. So next command is frequency. This time you take coffee. So all of you know how to use the frequency command. Next is tables. Here I let's say mashed potato versus illness. Or sometimes you find out there are, let's say 20 variables, 20 to 20, there's 400 minus 20, there's 380, divide by 2, 190. If there are 20 variables, you can have 190 such tables. That also you can use. Those who are well versed with SPSS, SPSS is also very good software. Only thing it takes 1 or 2 lakh rupees. So in Epi Info also is possible. Another thing is, let's say, so this you will be able to compare, right? So this is very simple, p values, etc. The means command, you will be using age versus instead of illness. What happens that the male and females having the same age or something was different. Female almost same, 36. So probably there is no significant difference as far as age is concerned between male and female. So last thing which you output, where is the output? Is over here, output 33.html. Here your output is saved automatically. So if you want to see that output file, you can go to the Epi Info folder, again Epi Info folder, and go for the output, and 33 numbers file which is given. It is a different thing, but the Epi Info, I will just, because I'm telling you, there are various folders of Epi Info on my laptop. So directly what you can do, if it is located 2 or 3 sites, simply go for this PC and then go for output file, output 33, and then you will be able to find out where is your file. These are at three level it is there. One of the file will be yours. So you can find out from that, and then that file you can use it. So here is our file, right? And this file you can go for editing in the Word file also and take your tables, whatever you want. So today, you know how to do the analysis, where it is stored, etc. And then we'll be moving to a few other concepts. Before that, any question you would like to ask? So I will stop sharing over here. And then we go to the other concept of standard deviation. And then next time with the table we'll be going. So I thought that all of you know how to use Epi Info. Maybe 5 to 10%. Any answer? Yes, okay. So if not, we have another 4-5 days. During daytime, you can connect with the Hitesh Bhai. After 2 to 3 days, I will give another Kalpesh Bhai, so that at least before on the Monday, we'll be able to go for the further theory. Now, all of you can do one thing, that the standard deviation. That day we talked about standard deviation. So if there are, let's say, 1,000 people are there, mean is 50 kg. We are taking a weight. Mean is 50 kg. Standard deviation is 10 kg. 1,000 people are there. So if a simple question is asked to you, that a person having 40 kg weight, will you consider is as a part of team or not? Let me write down in at least chat box. The n is equal to 1,000. Mean is equal to 50 kg. Young adults we have taken, right? And the standard deviation is equal to 10. Now my question is, if a person is having 40 kg weight, do you think that this person belongs to this group? Write down yes or no. This is a group of 1,000 people. We found out the mean that a 50 kg weight, the standard deviation was 10 kg. Yes, it is there, because how far this is. Now, bus, that's all. Or 1 or 2 answers is sufficient. Yeah. So now, here is my question is, suppose if a person is having a 20 kg weight, what will happen? This is a very important, looking very simple. If a person is having weight 20 kg, the expected weight, now remember this word, expected, and the reality or actual or observed. These two words you should write down in your notebook if you have. The expected value, observed value. Expected value, observed value. The whole statistics is based on finding out the difference between what are you expecting and what actually observed. This, if you write down these two words, your 10 to 15% statistics is over. First, if you know the variable, you can find out proportion, that means percentage, or you can find out mean. If you can find out variable between these two categories, your status is over 10 to 15%. If you know what is expected value and what is observed value, another 15-20% is over. So here, the 20 kg means 50 kg minus 20 kg is 30 kg. It is 3 standard deviation away. So it could be a part of this group, but it is less likely, because Z value. Now remember this Z value. Why we say what is Z? It shows that observed value, that is the X minus X bar. I don't know how to write X bar, but then you understand this X bar. Let me say that it is a bigger X, right? Divided by SD. If you remember this, automatically 5 formula you will be able to remember. Just remember this. The observed value and the expected value. The difference, observed value is 20 kg, mean is 50 kg, and divided by standard deviation. So what we are taking is absolute value. To just remove the effect of plus minus standard deviation. So here standard is 10, difference is 30 kg upon 10, so 3 standard deviation away. Now, if somebody tells you that you need to go for 1 kilometer, 1.5 kilometer, you say, okay, cycle is okay. But if Papa says more than 2 kilometers, the children will say, no, cycle is not okay. For that person, it measures in terms of the kilometers. Similarly, when you say the weight in terms of kilogram. But in terms of probability, in statistics, we measure the distance between observed value and the expected value in terms of Z. So this concept we will carry with us for rest of the things also. So here the Z is 3, means the probability of this person belonging to the group is there, but it is less than 5%. See, 95% are covered between mean plus minus 2 standard deviation. If it goes beyond, that means less than 5%. So in this case, Z, what Z measures? How far, what is the distance between mean and observed value? If it is more than 2 standard deviation away, that means less likely to be in the group. So we can say that the person, we cannot say mathematically that this person is not belonging to the group, because even 20 kg, even 5 kg person can also be in this group, theoretically. But likelihood is less. So this is how, when Z is more than 2, we say that probability of event occurring by chance is less than 0.05. That means less than 5%. This is why always we say Z is more than 2, P is less than 0.05 or less than 5%. So less than 5%, not in 95% zone, less than 0.05, all are almost equivalent. If you have understood this, you have understood a lot of things. And then we go for another concept. That is a little bit, you need to concentrate it. That suppose there is a, till now we were talking about individual with a group, individual whether belongs to group or not, in which you utilize this formula, that x minus x bar divided by standard deviation. If it is more than 2 or less than 2, you can find out whether the person belongs to or not. Or reverse way, you can go like this. X bar, there is a 50 kg plus minus 2 st. That is 50 kg minus 20 and plus 20. That is 30 to 70. That people will be belonging to group. 95%, raise the 5% outside the group. Here, you remember that we are not saying that they are not in the group. If we belong to standard deviation, we just say that less likely that they are in the group. Now, another, when you want to compare with the whole Ahmedabad, I'm staying in Ahmedabad, I want to find out the income of all the families of Ahmedabad, mean, right, and standard deviation. So, I need not go to the 70 lakh families. I can just take a small sample of 7,000, 5,000 like that. And based on the sample, I can talk about the population. But when I talk about the population based on a sample, will there be error? Yes or no? Write down. When I talk about population based on a sample, will there be error or not? Yes or no? Right? 2 or 3% write in the chat box. When I want to talk about population based on a sample, will there be error or not? Yes. So that error is known as sampling error. Yes, very good. That error is known as sampling error. When you want to talk about population based on a sample, there is a sampling error. And when you want to standardize this error, when you want to standardize this sampling error, you want to find out how much error you can allow. By chance, the word we use change, it is known as standard error. Standard is nothing but a one kind of standard deviation. You just write down in your notebook, standard error is nothing but one kind of standard deviation. Here, you just take a deep breath. We'll talk next time, but then I will just ignite the things. So, it's a wonderful, imagination. Imagine that there is, let's say, a 10 lakh population in a taluka, and you want to take a sample size of 10,000. I repeat, I have a population of 10 lakh and I want to take a sample size of 10,000. How many such samples I will be able to take? Just write down in the chat box. Population is 10 lakh, sample size is 10,000. How many such samples I can take? Write down in chat box. I repeat, population is 10 lakh. I want to take a sample size of 10,000. How many such samples I will take? Just quick answer. 100. Very good. Very good. So quick. So quick. Good. Any other? Any other? So the answer is the word 1,000, 100 and infinite. All these are not correct. Of course, infinite answer is near to the truth, but not correct. Because, see, when we want to choose 10,000 people out of 10 lakh people, you have a permutation and combination, right? And that permutation and combination you can calculate statistically. Right now, I don't want to go for that. But you have so many samples you can find out. Let us presume for time being that I am taking 5,000 samples, each composed of 10,000 population. I repeat, permutation combination, you change the people. So 10,000, 10,000, 10,000, I have taken it for 5,000 times. So because I have taken 5,000 samples, will I have 5,000 means or not? Yes or no? I think 3 or 4 people open your mic. Yes, right. So this is now very interesting. Now you have 5,000 samples, you will have 5,000 means. Agreed. Now on x-axis, you keep the 5,000 means, and y-axis write down how many means are having a particular value. So on y-axis, you will get a number. On x-axis, you will get the means. Now, what will happen when you draw the diagram? It will be inverted U-shaped diagram, standard normal distribution curve you will have. Now here, you can find out mean of the means. What you will be able to find out? Mean of the means. And that mean of the means, you can find out will be almost equivalent to the 10 lakh population mean. So you will say that why we should take, instead of taking 5,000 times, taking 10,000 people and then do all this nonsense thing, why should we be doing this? It is much better to just go for 10 lakh people and do it. No, it has some sense. When you are drawing the plot, this diagram, when you find out mean of the means of the samples, you will also find out the standard deviation of means of the samples around mean of the means of the sample. This is difficult to grasp, but next time when I'll use the chalk and board, it will be much easier. So this standard deviation of means of samples around that mean, right? Mean of the means, right? That is standard deviation. You can find out approximately by finding two things: the standard deviation of the sample and the size of the sample. From that, you can find out the basically how far that sample lies in the samples. And that by, if a standard deviation is more, there will be more sampling error. If a sample size is more, less error. So they found out that these standard deviation, they labeled as standard error, and they found out that without taking 5,000 samples, by taking only single sample of a 10,000 people, they found out that standard error will be into bracket, you can say ST square upon N. So that you need not take 5,000 samples. Automatically, you can find out population mean. Population mean is equal to sample mean plus minus 2 standard error. What is the standard error? Is basically a standard deviations of the means around the mean of the means of the sample. So that will take on the board, but this concept you must understand, because the standard error is important. What is that? When you want to talk about the population based on a sample, there is some error that is known as sampling error. When you standardize it with a specific method, that is known as standard error. And you can find out population mean based on a sample mean by this technique. So we'll stop over here, but next time I will try to use the board and will instruct everyone not to use my board. I will find out something whereby I can communicate to you more clearly. So for today, you should have a concept of something like this sampling error, there's something like standard error. Standard error is nothing but one kind of standard deviation. And I will be giving the lesson to you, very small examples. First, what you should be doing that wherever you are there, just collect a sample of 20, have your own Excel data, and then try to use the means command, try to use the tables command, use a frequency command, find out where is your file, and try to use the sample file of the Epi Info itself. And in sample file, there is a Oswego file, other file also. But then you can definitely go for taking help online also. But then in a 1 or 2 days, I will search the Epi Info manual, which are very simple. And there are tutorials, online tutorial available of Epi Info. One by one, you can go it, because our concentration will be on epidemiology. Ultimately, we want to find out the cross-section study, the randomized control trial, all this trial, and how to use Epi Info for the same. So now the forum is open for the questions. And I hope that all of you should write at least one question. You can go ahead, right? Uh, 38% there. Yes, sir, can you explain coefficient? Yeah, is a very important concept, coefficient of variance, right? See, I will give you a very clear example, and let me write in the chat box. I have a 1,000 population, let's say male, right? Whereby I have a mean weight is around 50 kg again, and the deviation is 5 this time, and another 1,000 female, and their mean weight was around 40 kg, but their standard deviation was let's say 10. Now, or let us keep like this. So what happens over here? The variations in the male is 5. 5 is the standard deviation. While the GAG is not able to open sample file in the Epi Info, no problem. You need to locate your Epi Info folder, or 2 or 3 times. It will be at 2 or 3 places. One of the place it will be able to locate. That will, or others will talk it with a team viewer during daytime with my colleague. And if they fail to do it, I will do it. So here the covariance in the female 40 kg and 10. So in male, what is the covariance? So covariance is 5 divided by 50 multiplied by 100. That means 10%. While in female, 10 divided by 40 multiplied by 100, that means 25%. So if someone asks you, where is more variation, in the females or male, then you can compare the variance. One is 25%, other is 10%. So you can compare where the variations is more. So when you want to take a sample, for example, in this case, if you want to go for sample size calculation, in male, even if you take a small size sample size, it is okay. But in female, you will have to take more sample size, because more variations, there will be more error in about talking about the population based on the sample. So the covariance is very useful for your interpretation as well as calculating the sample size. So when I talk about sample size, let me ask one more question. In one taluka, I have a population of 5 lakh, and another taluka, I have a sample of 2 lakh. Whether the sample size calculation will differ or not, right? Yes or not? One taluka 5 lakh population, I want to find out the sample size, and from another taluka where the population is 2 lakh, whether the sample size will differ or not. Yes or no? It will differ. Yes. So I give you another example. Let's say that Maya Kalyani Srivastav, you have kept a birthday party and you have invited 500 people for the birthday party. And at that time, you have also prepared Dudh Pak as a, let's say, what we call it as a sweet milk. And usually in your home, you prepare milk for around 10 people, sweet milk. So when you want to take a taste, so if you prepare for 10 person, you just taste 1 chamach. And when you prepare for 1,000 people, you taste 1 liter or 2 liter. Yes or no? If you cook more, you need to taste more. Yes or no, right now? No, because sample is basically for the tasting. Sample size usually do not depend on population size as far as there is a homogeneity of the population and population is not too large at the time. Sample size does not depend on population size, and that's why when we talk about it, we'll understand this. Anyway, you can go ahead with any other questions. At least I'm enjoying talking with you. I don't know about you. Yeah, expected value and observed value is a wonderful concept, and this we must understand. Suppose you are having 100 people and all of them are having weight 50 kg. Suppose all from 50 kg. So some person from outside can come and say, no, I belong to your group, and the person is having a weight 100 kg. What do you think? If he is to be belong to this group, his expected value should be around 50, but that person is having 100 kg weight. So what is expected is usually based on your the data, you want to find out what is the mean, what is usually belong to the group, what will the deviation will be, standard deviation you can find out. So again and again, expected value and observed value in the chi-square also you will have. You will also have a Z-test. There are 5 types of Z-test, and there are 1 type of chi-square test. In that also you can yes correction, etc. So we'll go for the next session. I think I enjoyed talking to you. I don't know about you, but I can attend only last one question, and then so if I have saved the Excel file 97 version, it is not uploading, so that will go through the team viewer. And as far as possible, you try to interact with your 5 person in your group. Out of 5 person, I say that usually 1 person should be able to do it. You try to talk to in between with each other, and then we'll be doing a practical on you with a team viewer, right? There could be another problem. You might not have selected the types of the file while going. It is Epi Info project and you are selecting Excel file. It will not find out. So you need to exactly.
No, sir, I'm not doing that, sir. I have selected it as Excel 97/2003, and even if I have selected browse the converted file, it is not uploading.
That means it is not matching. We'll see through the team viewer, right? Because it will show only if you have selected something, it is the same matching, then only it will show, other it will not show. So it is better that you go for Oswego file of the Epi Info project. You find out among the project the sample file, and then you will be able to start learning on that, right? And with team viewer, we'll be able to locate that file. This is only a second session, and we don't expect you to be a master of that. But when we start a third session, If you by that time at least know this 3-4 command, your live data you will be able to start analyzing. At that time will have a more charm in learning the statistics and epidemiology. Anything else? So I hope that you will talk among your groups, and I have already given you the number of Hitesh Bhai, and between 11 a.m. to 4 p.m. you can connect to him. And if still there is a problem, next day I will be sitting to you, particularly those 1 or 2%. I will take your charge on TeamViewer and we'll see why it should not work. Right? Okay. Thank you all of you.